Dear all, we would like to provide you an update following the launch of the HandySCAN Max. This presentation aims to give you valuable tips and tricks for delivering the best demo to our customers. It will also address the frequently asked questions we have received so far. After 1 month, we received highly positive feedback on the product, especially regarding its speed in scanning large parts and how well it addressed this market. Additionally, there's appreciation for the level of detail that can be achieved while using fewer targets on the object. However, there have been comments about the ambient noise generated and inquiries about the scale bar's placement, as well as how to merge scans acquired at different working volumes. I hope that it will help you in the comprehension of this device and ultimately enhance your demo. As you know, our scanner offers three distinct working volumes within what we refer as the flex volume. However, when initially developing this project for large-scale objects, the scanner was primarily designed for use within the standard working volume. The term working volumes refer to the working distances within which scaling is feasible. This scanner operates optimally within the range of 45 cm to 1.6 meter. For optimal result, the ideal distance for using this scanner is 1 meter, commonly referred to as the standoff nominal distance. One thing that we discover is that the scanner was able to scan closer to the object than initially anticipated. We introduced a near volume that is specifically designed for smaller objects, ensuring a high level of detail due to its close standoff distance from the part. Additionally, using 12 mm high reflective targets, we realized that the HandySCAN Max can capture data even from further distances with a nominal standoff at 1.8 meter. The far volume is intended for scenarios requiring low target density, delivering scans with lower resolution suitable for certain applications where accuracy and resolution are not the primary concern. Both these modes should be presented as extras to customers, especially for projects that fall beyond the scopes of the standard working volume. The target density typically remains around one-third of your chosen standoff distance. In the context of the standard working volume, this translates to a target spacing of approximately 30 to 35 cm. When using the HandySCAN Max, we strongly recommend beginning with scanning the positioning targets. Why? Because this approach streamlines subsequent acquisition and optimizes accuracy. First, it enables faster and easier capture of the entire model from a greater standoff distance. It also helps to focus capturing the positioning models from various angles, ensuring better coverage that will enhance accuracy. Additionally, it serves as a valuable demonstration for the customer, allowing you to explain the benefits of the target quality indicator. It also illustrates the photogrammetry concepts with the use of the scale bar. As a reminder, it is essential to showcase all the accessories included with the HandySCAN Max in demo, as they collectively offer a comprehensive solution for the user. The clip cards are particularly impressive, generating a wow effect by automatically creating a bonding box of clipping plates. They significantly help removing unwanted data while reducing the computing resources required. Additionally, the 360 magnetic targets contribute to faster setup times and are reusable. Highlights the automatic hole fitting feature they offer, which improves post-processing manipulations. Another nice feature is the phone mount adapter. It allows users to concentrate on their acquisition process while keeping their focus on the object being scanned. Remember to use the multi-function buttons during your demo. While the center, up, and down buttons retain their original functions, the HandySCAN Max assigns different functions to the remaining two buttons. The left button grants access to the smart control, while a double click serves as a shortcut to exit. The bottom of the particular importance is the right click, which allows entry into high resolution mode when required. Additionally, a double click on the right button switches from the normal view to the touchscreen mode, especially convenient when using your smartphone. Furthermore, you can alternate between these two views using the icon located in the display option at the bottom of the 3D viewer. As we've just seen, the high-resolution mode has a dedicated button on the scanner, really advantageous in practice. This functionality enables users to quadruple the resolution precisely where it's required. Understanding this function involves simulating the working volume closer to the part. For instance, transitioning from the standard working volume with the high resolution mode will bring you in the near volume, with specific restriction that comes with it. For high resolution, proximity to the part becomes crucial, approximately 500 millimeters, aligning with the nominal standoff of the near volume. You also have to ensure the target density is appropriately adjusted, roughly 1 per every 15 centimeter. Under the specified condition, it can grant access to the scanner's highest resolution of 0.4 mm where it's needed. During the development of this new product, we encountered some challenges, and while many bugs have been addressed, some persist. The most significant known issues is the occurrence of the floating noise around the part. Our R&D team is actively engaged resolving this matter, and even if improvement has been made in the upcoming release, it is not totally fixed yet. Please note that this bug does not affect the scanner's accuracy. Instances where this behavior occurs more frequently include scanning objects with surfaces at multiple standoff distances within the measuring volumes, scanning at a greater distance from the object, especially within the far volume, scanning an object without any background, and we notice that this behavior occurs more with high shutter value. To minimize floating noise during demonstration, we recommend the following. Use the near or standard working volume, maintain a mostly perpendicular orientation to the surface and avoid to scan with steep angles, use clip cards as they will help hiding some of the floating noise, and ensure that the scan is clean before finalizing the process. Rest reassured, addressing this bug is our foremost priority. We also had several questions about the calibration of the scanner. The user calibration should be done under the following cases. After traveling with the scanner, prior to conducting any benchmark test, during a project that doesn't involve a scale bar, or in case of acquisition issues. We've also introduced a real-time calibration feature which continuously updates the previous calibration for optimal results. During surface acquisition, the lasers are calibrating using the surface itself. The scaling of the positioning model is adjusted during the finalization process at the same moment than the distance between cameras. We've received inquiries regarding the positioning of the scale bars. Actually, the same principles observed with the backshot photogrammetry setups should be applied. The scale bars should be positioned within the scene, ideally near or on the object and surrounded by targets. Ensure that the scale bar is parallel to the main axis of the object. For multidimensional objects, select the two primary axes and locate the bars in the middle of the volume. For linear objects, align both scale bar parallel at 1/3 and 2/3 of length. It is imperative to scan the scale bar from various angles to accurately capture all targets. This approach guarantees the precision of the scaling model. We also had questions about merging scan from different volume. At this moment, merging scan from different volume is not yet available due to this challenge posed by varying data quality resulting from different send-off distances. The most viable option is to use the high resolution feature, enabling scanning at different resolution within the same scan. As mentioned, employing high resolution relocates the user to a working volume closer to the part, providing the resolution required. If the use of the high resolution is not compatible with your project, an alternative approach will be to use the same positioning model and after that merge the STL file in VIX model. I encourage you to continue sharing both positive and constructive feedback regarding the HandySCAN Max, as it greatly assists us in enhancing our product. We highly recommend familiarizing yourself with the device and dedicating time to practice. The recommendation highlighted in this presentation aims to support you during your next demo, and I hope that it will serve you well. Thank you for your attention.